Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In this new episode, I'm going to write an allocator class that keeps track of resource descriptors for our graphics resources. I will start with a high-level explanation of resources, descriptors, and descriptor heaps, and will continue implementing the allocator class. Let me start by correcting a mistake that I made in the last episode, where I accidentally typed ifdef instead of if. Because with ifdef, this code is always included. Test renderer is defined anyway, whether we set it to 0 or 1, it is always defined. But if only includes this code when test renderer has a non-zero value. So that fixes that issue. And I'd also like to give our test windows a bit of a more descriptive name, like render window. I would also like to explain something that I glanced over in the last video, and that's this initialization of graphics command. Here we use a placement new, which constructs this object in a space that is reserved during the initialization of this application. Here we have an instance that uses the default constructor to initialize and reserve space here in data segment of the application. And in this place, we are going to initialize another instance of this class using a placement new. And what this does is just overwrites everything that was already in there. And that means that if this class happens to have some resources reserved during its default initialization, because it had something in its member variables that would reserve some resources, that would get overridden. And that would prevent it from destructing correctly, because we are not calling the destructor here before putting the new instance in there. And that's fine for something that has only primitive types in it. As we have here, we have only a pointer and some integers. Here in this command frame, there is also a pointer and an integer. So there's nothing really that gets initialized during the default construction, and it's okay if we overwrite the initial values. But let's say if we would have something like a vector. Now, if we would build and run the application, you could see that we will get a memory leak because vector allocates some memory at initialization. And when we override this instance with a new instance, this vector is not destructed correctly. Now, if we look at the output panel, you can see here that we leaked 16 bytes of memory just because we didn't call the destructor of this vector. So that's something that we need to really be aware of. I didn't explain it in the last episode. That's why I'm doing it now, because something bad could happen with non-trivial data types. Now, with that out of the way, we can start implementing the descriptor heap allocator class. Before writing the class, I'd like to explain a bit about resources, descriptors, and descriptor heaps. This is going to be a high-level and condensed explanation, so I highly recommend reading the online documentation for a deeper understanding of these subjects. While rendering a scene, we need to provide the GPU with the information needed to render the objects in the scene. We can provide this information using resources. Vertex buffers, textures, and constant buffers are a few examples of types of resources that we can use. With some exceptions that we'll discuss later, we often need to tell the GPU how a particular resource will be used. We can provide information about the purpose and format of a resource using resource descriptors. A descriptor, also referred to as a resource view, tells the hardware in what way to view the resource it's describing. As an example, consider a texture that has multiple MIP levels. We can render to this texture while viewing it as a render target. Subsequently, it can be viewed as a shader resource in a shader, which will blur and render it to the next MIP level. As you can see, the same resource may have multiple views, or descriptors. A descriptor is a small block of memory with a GPU-specific opaque format. Not considering the ray tracing part of D3D12 for now, there are 6 types of descriptors: render target views, depth stencil views, shader resource views, unordered access views, constant buffer views, and samplers. The memory in which descriptors are created is provided by descriptor heaps. It's not possible to use any other memory allocation mechanism to reserve memory for descriptors. A descriptor heap is in charge of hosting memory that can be used for descriptors. The size of each type of descriptor will vary from GPU to GPU. Therefore, we need to use a dedicated heap type for different types of descriptors. The size of shader resource views, constant buffer views, and unordered access views is always the same, so the same heap type can be used for these. Other heap types exist for render target views, depth stencil views, and samplers. Descriptor heaps can be shader visible. That means that they can be bound to the pipeline and accessed by shaders. In that case, the memory is most likely allocated on the GPU and mapped onto system memory. Otherwise, system memory is used to host the descriptors. Heaps that contain render target views and depth stencil views can't be shader visible. Similar to regular pointers when we allocate memory, we'll get a descriptor handle when we allocate a slot on the heap. This handle is basically an offset relative to the base address of the heap. Shader visible descriptors have both a CPU and a GPU handle. It's not recommended to write to the heap directly. Instead, D3D12 API provides us with functions that we can call to create and copy descriptors. We give the information about the descriptor and the descriptor handle that points to an available slot on the heap, and the function will create a descriptor at that location. Keeping track of available slots is the responsibility of the programmer, and that's the reason that we are going to write a simple descriptor heap allocator class. Now let's continue and add the source files. Because descriptor heaps have to do with resource management, I'm going to add a file here and call it D3D12 resources. Here I include the common headers for the D3D renderer. Because we are going to create a descriptor heap, we need a member variable that holds the pointer to that interface. Yes, thank you. A heap is basically a chunk of memory, and depending on whether it is shader visible or not, it is allocated in the system memory or in the GPU memory. So we need to have pointers to both of those. This is the base address for the heap that is accessible by the CPU. When the heap is shader visible, it will most likely be allocated using the GPU memory, and that memory will be mapped to system memory, which gives it a CPU accessible base address. So in that case, we have both the CPU start and the GPU start pointers. And if we open the definition of these structures, you can see that in case of a GPU descriptor handle, it's a 64-bit unsigned integer. And the same is also true for the CPU descriptor handle. This size t is 64-bit when the application is 64-bit, and it's also unsigned. Next, we need to remember how large this heap is, and that number is contained in capacity. We also keep count of how many descriptors have already been allocated. And because different kind of descriptors could have different sizes on different systems, we need to remember what the descriptor size is for this particular type of heap. And of course, the type itself. And we also need an array that contains the indices to slots in the heap that are available for allocation. This is a pointer to a buffer that contains 32-bit unsigned integer values, and it will have the same length as the capacity that we are going to initialize for this heap. And granted, we could have used a vector, but because we need a fixed number of elements here, I'm just using a unique pointer. Next, I'm going to define a constructor for this class. And the only thing we do in this constructor is to set the type of the heap that we will be initializing later. And I'm splitting the initialization of the heap and the constructor for two reasons. The first reason is that we are going to have some non-trivial data types here later on, and I'm going to also disable copy and move for this class, as we did for the D3D12 command here, to prevent the instances to be assigned to each other and copied over. But now, because we will have non-trivial types in our class, that means that I can't use placement new anymore. And the second reason is that it will enable us to resize this descriptor heap later on if it proves to be too small for a particular scenario. Here we have a destructor that just asserts that the heap is released. Next, we have the initialization function. And here we set the capacity and whether this heap should be shader visible or not. And we need a release function as well. We also need two functions to allocate and free descriptors. Similar to a regular memory allocator, we need to give back a pointer to the allocated memory when we call allocate. And therefore, I'm going to create a structure that we can use, which is called a descriptor handle. And we can have some helper functions that we can use to determine whether this handle is valid or not and whether it is shader visible or not. We can determine whether this handle is valid the same way we do for a regular pointer, which is just to check whether it is 0 or not. Also, only shader visible descriptor handles have a non-zero GPU pointer. So if that pointer is 0, that means that that handle doesn't belong to a shader visible heap. Next, only for debugging purposes, I would like to remember on which descriptor heap this handle was allocated. And that I can do by simply having a pointer to this descriptor heap. Because I chose these members to be public, and therefore they could be set accidentally to other values than their original value, I'm going to remember the index of that slot in the heap. And that means that I can just calculate this index and check whether these values are still correct or not. And because we are going to access these private members in the descriptor heap, we need to make this class a friend of this structure. And we also need to forward declare this class, so at this point we know that it exists somewhere. Before getting to the meat of this class, I'm going to add a couple of accessor functions to give read-only access to some of these member variables. Now we are ready to go ahead and implement these 4 functions. Therefore, I need to add a CPP file for this header. First, I need to include the header for this file. Now, because I'm going to put more class implementations in this file, I'm going to add a banner here that marks the beginning of each implementation, so it makes it easier for me to find the class implementations later on. Okay, let's start with writing initialize function. One thing that we need to consider is the fact that this class will be used by different threads. And that's because descriptor allocation happens most of the time when we are creating resources like textures. And loading resources and creating those can happen on different threads. And that's why I need to protect the data in this class from data races. And we can do that simply by using a mutex. And to use a mutex from standard library, I need to include its header. Then we can simply have a lock guard here. And I'll put this in the allocate function and in free function as well. Now to create a D3D12 descriptor heap, we need to have access to the main device that we created during the initialization. Here in core CPP, we have this main device, but it is internal to this translation unit. Therefore, I'm going to add a function here that will give back a pointer to the main device. Now here, if we include the header for core CPP, we can access that function. And also we assert that a device is not null. And before we use this device to create a heap, I'll do some other checks as well. Namely that the capacity is not null because we need a minimum capacity of 1. And that the capacity doesn't exceed a certain value that is defined in the 3D12 header. Here in the 3D12 header, we can see a lot of resource limits and constant values that is used by the API. And there are 2 constants defined here, one for tier 1 and one for tier 2 devices. And both of them happen to be the same value of 1 million descriptors. So as long as we are not initializing a heap that has more descriptors than this value, then we are good. Now in case that we are trying to create a heap that will hold sampler descriptors, then the maximum capacity is defined by another constant, which is defined to be 2k. Now these values are only limiting to shader visible heaps, but I'm going to limit even the non-shader visible heaps to these values as well. Now for some descriptor types, there is not possible to create a shader visible heap. And those types are the descriptors for render targets and for depth stencil resources. So for these descriptor types, we set isShader visible to false, regardless of what was given to this function. Now, because this initialize function can be called multiple times, we need to first release anything that might have been created before. And now we are ready to create our heap. To create a descriptor heap, we need to give this function a description structure. So let's fill that out here. If the heap is intended to be shader visible, we set the flag. And of course, we need to check whether this function succeeded or not. And like before, we use an h result. If this function fails to create a descriptor heap, then we will jump to the end of the function where we release everything that might have been created and also return false. Next, we can create the array of free handles. Here we populate this array with the indices of that slot. So basically it says that every single slot in this heap is available for allocation. Next, we get the size of the descriptors for this heap type, and we'll need this value to calculate the pointers for each descriptor handle that we will return during allocation. Finally, we get the pointers to the start addresses of the heap in CPU memory. And if it is a shader visible heap, we get the GPU-based address as well. Now, since this function call is the only point in this function that has the biggest chance of failure, we can just return false here. And here we return true. Next, we can implement the allocation function. Here we check that the heap has been created. And we also check that the size or the number of allocated slots is less than the capacity of the heap. Otherwise, that would mean that the heap is full and we can't allocate any more descriptors here. Here we take the next available slot index and we calculate the offset with respect to the start of the heap by multiplying this index by descriptor size. Here we calculate the address of the memory location that we are trying to allocate by adding the offset to the start of the heap and put it in the CPU location for the handle. And if this heap is shader visible, we need also to generate a GPU pointer, which works the same as for the CPU pointer. We just use the base address for the GPU memory. And as a last step, we use this debug operation to set the container pointer of this handle to this instance of descriptor heap class, and also remember the index in the heap. And then we can go ahead and write the free function. Like it happens for regular pointers, when we give the free function a null pointer, it should just return and it's fine. So here we check if this handle is valid, and if it is not, then we just return. Then we do a couple of checks to see if this handle is within this heap and if it belongs to this heap at all. Here first we check that the heap exists and that there have been some allocations. So if this heap is empty, then we can't obviously have a handle that belongs to it, right? Next we check that this handle indeed belongs to this heap, and also the address of the handle should be greater than the CPU start address. Then we check that the location of this pointer is a multiple of the descriptor size, because if it ends up being halfway through such a slot or memory chunk that is normally a descriptor, that would mean that it's a wrong type of descriptor and something has gone wrong. Next, the index of the handle should be less than the capacity. And we also explicitly calculate the index of this slot using this formula, which is the offset of this pointer with respect to the start of the heap divided by the descriptor size. That gives us the index. And then we make sure that these two indices are the same. Here first we need to free the descriptor memory and then return a handle that is a null pointer basically. But before doing this, I need to remind you of the fact that we have multiple frames in our renderer. So while we are trying to free some resources or descriptors, those could be still referred to by a previous frame that is still being rendered on the GPU. So we can just plain go ahead and remove a descriptor or a resource or unload a texture and those kind of things. We need to defer those operations to after a point that we know for certain that that resource or descriptor is no longer needed in the GPU or being referred to by a shader. In the next video, I'm going to add a deferred release system that we can use for freeing resources safely. Then I'll also finish writing this heap allocator class. Thank you so much for joining me today. If you like the series and would like to recommend it to others, you can do so easily by liking the videos, subscribing to the channel, or leaving a comment, and YouTube will do the rest. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering.